Hey, welcome. This is a part 3 video of GPT-3 explained. In today's video, you will learn how to build machines that can learn as efficient as humans. Definitely not as efficient as human, but trying to make it maybe 80%, 70% as efficient as human. It's also a goal that DeepMind and OpenAI want to achieve, which is general artificial intelligence. So how to do that? They propose a way called in-context learning, or you can say that's zero-shot learning. Basically, it's a way they require no data or very little data, then can let the machine to perform very complex tasks like human. You don't really need to look at thousands of examples to perform a certain complex task. You probably just need a description, or you just need to see 1 or 2 demonstrations, then you can perform very complex tasks. Yes, and there will be more GPT-3 explained videos be released in the future. So if you enjoy the video, make sure you subscribe so you can get the notification in the first place. Humans is a highly efficient learning animal. If you want to learn something, if you want to perform certain task, you probably, if you even you never seen that task before, you probably just need a very brief description or a few demonstration, then you can perform the task relatively well compared to machines. For example, please tell me if this sentence describes something happy or not. You probably just need to read this instruction, then you can perform a task maybe at for the accuracy 90%, 95%. In contrast, most models cannot do that. Most models are very narrow experts, and they are narrow experts. They only can perform one task specifically, but they still need to look at more than hundreds of thousand data points to learn how to perform that very specific, very narrow task. So remember this graph that we discussed in the previous video. Even you have language model here. You plug in a language model, you can make your model in general much more data efficient, but you still need to let your model look at over 1,000, over 10,000 data points to perform certain tasks. And more unfortunately is that even your model is a task maybe in sentiment analysis, but your model will not be able to perform some other task. For example, name entity recognition or coreference, some other NLP task. But it's not the case for human. For if you know how to classify, how to analyze a sentiment in English, you should be able to know how to extract name entities very easily, right? So they just proves that the machine learning approach now, the conventional deep learning models are not really close to human, not even close yet. And OpenAI's goal is basically try to make a model that has very similar learning mechanism as humans. So the problem with fine-tuning approach, just like I said, we really need a lot of label data, and label data is extremely expensive. It's very different from just using a research benchmarking data set. If you really need to solve the real world problem, usually they kind of problem has no any label data, then you need to spend a huge amount of label resources, or you put huge amount of money to ask other people to annotate for you. But those label data can only be used to let the machine to perform their very particular task. When you need to do another task, even if it's slightly different, then the machine cannot do that at all. You need to restart the process, the whole process again, which is very time consuming and expensive. And also, if you train this model, expert model, it's still like the problem we mentioned, a lack of the generalization. If the model now doing sentiment analysis, maybe on the Amazon review, if you throw then, if you show the model some other kind of a review, maybe it's the Yelp review or the review for fashion or the art, they kind of review very different from the Amazon products review the model saw in the training time. The model couldn't perform, even this is similar task, sentiment analysis, but the model couldn't perform. This is kind of the lack of generalization. Models are very bad. These kind of models are very bad at handling out of distribution data, and also sometimes they have a very weird behavior. For example, in previous studies, someone found that you just for the QA question answering model, reading comprehension model, which will show model an article, the model need to ask a model a question, the model need to extract the answer from the article. Then you just need to insert some stop word or some weird vocabulary. Just insert one word, then the model accuracy just drop from. Originally, model can perform as good as humans, but you just insert certain weird word, then the model's performance is barely better than random guessing. But instead, humans' performance didn't get affected at all. So that's the proof that the fine-tune the model they train with the model they train with supervised learning really lack of generalization. This is not really the strong proof, but it's the direction they can give you, the sense that you can have. Then OpenAI, they want to address this problem, and also recently people also realize this problem, and they realize that if you really want to build robust systems, this robust system should be able to perform a variety different tasks. So they invented like glue and super glue, which is a set of NLP tasks that if you really want to prove your model is very powerful, you need to perform well on the super glue, which contain probably around 10 NLP tasks. So people try a lot of approach to make the model more generalizable. And the previous approach to solve this problem was to train a multitask model. Basically, it's like a model then train on a lot of different downstream tasks at the same time. But the problem with that is you really need to have a lot of label data for many different tasks, and you need to combine them. Combining them is trouble, and how to write a loss function that can handle that many tasks also is a very tedious thing, and it's not really scalable. Imagine if you want to do the model that's trained on the multitask, and the number of tasks is 100. Then how do you write a loss function for that? You probably need to brute force to do that, and there's also not very significant effect that when you do the multitask, then you can reduce the number of label in one task that you need. Basically, you still need a very similar number of label data points to have a similar performance as a single task learning model. So it's really, really hard to scale. And I personally also don't really like this approach. That should be something else to solve to make the model more generalizable. So let's take a flashback to February 2019, the time that GPT-2 was released. And if you ever read the paper, it was actually very interesting, because the GPT idea, the core value of GPT-2 and GPT-3 is to make a model that's more generalizable, that more like how humans learn, and it's definitely a step to artificial general intelligence. So the paper of GPT-2 was language models are unsupervised multitask learners. It's a way they use the same zero-shot learning to do many tasks. But it's very different from the supervised multitask learning. The approach here I mentioned is a supervised multitask learning. If you ever done this, you will probably find this very troublesome. For example, if you want to do name entity recognition and you also want to do sentiment analysis, then how do you combine this label? You probably need to have one utterance state, content entity, and also label its sentiment at the same time. Creating this kind of label is very, very troublesome. So that's why GPT-2 wants to use unsupervised way to solve this problem. And now we have GPT-3, and the paper name, official paper name, is Language Models are Few-Shot Learners. And you can see the number of authors increase very, very drastically. So probably this tells us OpenAI invested more money and effort in making very generalizable language models. And OpenAI defines a spectrum of learning. There are basically 4 different ways of using language model. One is most typical way. The first one is the most typical way, fine-tuning. It's like I mentioned earlier. You have a language model, then you plug in your prediction layer and use the supervised learning method to update your gradient to let your model know. And they use GPT-3 to explore these 3 methods: few-shot learning, one-shot learning, and zero-shot learning. I will explain in a sec. So let's visit the traditional fine-tuning first. Basically, in this example, I believe it's a machine translation. Then utility model, you give the model answer first. English, translate English to, it's probably French, English to another language, to your target language. Then a model do the prediction first. Model had no clue in the first place, but it would make a prediction. Then you tell the model how far away, how wrong are you from the correct answer. The model makes some correction to it through updating its gradient, to updating its neurons weights, its neural network weights. Then model become better. Model make another prediction to another example, probably. Then maybe model is still wrong. Then you tell the model how to update, what's the direction you should go to. The model updates gradients. And then gradually model become better. And this kind of fine-tuning usually requires more than 10,000 examples, especially for translation, this kind of complex task, which is not really data efficient at all. That's why OpenAI try to explore 3 different ways which require no gradient update at all. So first one, they define is zero-shot learning. It's like translate English to French. You just give the model this prompt, this description, task description, translate English to French. Then you write your English sentence first. Then the model will know, oh, actually you want me to translate English to French. Then you will translate to the French since it should be what it should be in French. This is definitely super challenging. Can you imagine? You don't do any gradient update to the model can understand the task just by reading this text. This is almost insane. And model not only can do this in translation, it can do this for over probably 50 different NLP tasks. This is super crazy. And another is called one-shot learning. Basically, it's similar to zero-shot learning. You give your model description, but the difference is you give model one example. This example is English to French. The model, after looking one example, it needs to predict what should the cheese be said in French. And the last one is few-shot learning. Basically, it's like you give model several examples. In OpenAI's paper setup is to give the model 32 examples. Then the model will need to predict how to say cheese in French. 32 examples, still pretty few compared to the fine-tuning. They use easily to over 10,000 examples. So, and more importantly, they didn't do any gradient update. If you use 32 examples, but if you still do a gradient update, that's not that impressive. The truly amazing thing is they don't even need to update your model. The implication is this: it will be super easy to use, super adaptable. Everyone can use. Even you don't understand how to do the neural network training, you can still use GPT-3. So that's kind of a different level of accessibility in terms of AI model, right? So to demo how much the examples for few-shot learning affect the performance and how much the natural language prompt increase the performance, we can actually see from this chart. So this chart is they train the different sizes of model from 1.3 billion parameters to the largest GPT-3, 175 billion parameters, to perform the task or scramble task. It's like they insert the random punctuations to a word, then model needs to remove those punctuation marks and recover it back to the original word. And you can see if model sees no example, which is Zeroshot Learning, then the accuracy is pretty low. That's definitely pretty understandable, because if you don't tell model how to do this task and you don't explain to the model, like you don't even give it a prompt. The prompt is a brief description for the task, say like you need to remove the random punctuation. If you don't even give that and don't give the model any examples, model almost cannot perform the job. But if you just give the model a little description, the model can get like 10% of accuracy without seeing any examples. And then you can see then when you increase the number of examples, the model's performance increase very quickly. This is the example. You give me one example, which is one-shot learning. And one-shot learning for the largest GPT-3, one-shot learning already can achieve like quite high accuracy, and especially when you give it a prompt, its accuracy already close to 50%. And for the smaller model, 13 billion and the 1.3 billion, this is like the similar size to the bird large model. Their performance actually did not improve too much. Even you give the model 32 examples, like here, the performance is still pretty much very low. And so that's just tells us when you increase the number of parameters to the language model, its language capability just increase drastically, especially like over a certain threshold, like this GPT-3. Give us this feeling. And also, when you give no prompt, the model performance is much lower than you give a prompt when the number of examples is very low. So it means model can actually understand the natural language description of a task, right? Like this, translate English to French. Model somehow can understand that. That's amazing. Imagine how much language it needs to read to understand that, because that's not in your training objective. Your training objective is just language modeling to predict the next word, right? I always find this fascinating. That's why I feel kind of scared and excited at the same time when reading this paper. How can a model understand that by just predicting the next word in the pre-training time. Right, that's why this paper is so exciting. In order to understand how much GPT-3 can do with in-context learning, how capable it is compared to those supervised or some other approaches, they evaluate GPT-3 on a lot of different tasks, and those tasks can roughly be classified into these 9 categories. And I will make the videos to introduce them. Probably I will make 2 or 3 videos to introduce them separately. So the first task they evaluated on is completion task. Basically, some of them are language modeling, and some of them are fill in the blank. Basically similar things. Give you a context, then you need to predict the missing word, or you need to predict the next word, sort of. And the second one is closed book question answering. It's like I give you a model one question, then model cannot look at the corpus data. Model need to answer that immediately, only by using its neural network weights, its memory they already store in the neurons. Its neurons. So it's quite a difficult task. If model didn't really memorize that, didn't really learn that in the inference time, in the training time, the model will not be able to answer it correctly. And so on. It's very straightforward. It's translation task, which is also quite crazy because GPT-3's data is training data 90% or 95% of the training data was English. Okay, and another is Winograd style task. Basically, it's like to figure out which word a pronoun is referring to. It's a very difficult task. And common sense reasoning, reading comprehension. Give you an article, then model ask a model a question. Model can access this article to understand what the answer is. So it's different from the closed book question answering. And superglue is a super data set to evaluate a model's understanding of language, especially in English. And natural language inference is a way to evaluate if model can understand the relationship between 2 sentences. And the last one is a synthetic and qualitative task. They made up some tasks, quite interesting tasks, to kind of prompt the model, and also they analyze the model's prediction qualitatively. Hey, congratulations! We have reached the end of today's video. In the next video, I will be explaining how GPT-3 perform on several NLP benchmarks. And that will be probably very interesting to look at how much GPT-3 can do. It's very powerful. It's very powerful. It achieved a lot of state-of-the-art results. So that's super exciting. And yes, so if you like the video, give it a like, and if you would like to receive more deep learning videos like this, including GPT-3 Explained series, don't forget to subscribe. And other than that, take care, and I will see you in the next GPT-3 video.